In this video, we will learn about measurements and units. Density is calculated from two measured quantities, mass and volume. Whenever we take measurements, the numerical values we record always have associated units. Units are standard reference quantities used to measure other quantities of the same type. For example, mass can be measured in ounces or grams, but in science we typically use grams. Common units for volume include cubic centimeters, milliliters, and liters. Because density is equal to mass divided by volume, the units for density are a mass unit divided by a volume unit, such as grams divided by milliliters. A number without units is meaningless. If I tell you that my commute is 13 long, that information is unclear. Do I mean 13 miles, 13 feet, or 13 kilometers? Or do I mean 13 minutes? Similarly, if I say that my daughter is 13 old, do I mean 13 days, 13 months, or 13 years? The key idea is that every number must be written with its unit. In science courses, we use the SI unit system, which is the basis of the metric system. In the SI unit system, we must first identify the base quantity being measured, such as mass, length of time, or temperature. Each base quantity has an associated unit. The official SI unit of mass is the kilogram, although in science labs we often use grams because kilograms are impractically large. The SI unit for length is the meter, and the SI unit of time is the second, and the SI unit of temperature is Kelvin. SI stands for International System of Units. The United States is one of only 3 countries that has not adopted SI units as the primary unit system. Even so, metric units are common in everyday life. For example, a large bottle of soda sold at a grocery store as a 2-liter bottle of soda. SI units are the standard unit system in science and medicine because they are based on the powers of 10, which makes calculations simpler and more consistent. You may have noticed that volume was not listed as a base quantity. Volume is a derived quantity because it is derived from length. For a rectangular object, volume is calculated by multiplying the length times the width times the height. If we have a cube that is 1 centimeter by 1 centimeter by 1 centimeter, the volume is 1 cubic centimeter, written as 1 cm to the power of 3. 1 cubic centimeter is equivalent to 1 milliliter. On the right side, you can see a syringe commonly used in healthcare. The units on the syringe may be labeled as cc, which stands for cubic centimeters, or as milliliters, because these units are equivalent. In addition to unit symbols, metric units often include prefixes. Metric prefixes represent powers of 10 and are placed in front of the unit. For example, the prefix tera has a symbol of capital T and represents 10 to the 12th. When you see a capital T in front of the unit, such as TB, it means 10 to the 12th. Another prefix is nano, which has a lowercase symbol of lowercase n and represents 10 to the minus 9. 1 nanosecond, written as 1 ns, is equal to 1 times 10 to the minus 9th seconds. SI prefixes can be used with any metric unit, such as grams, moles, seconds, or liters, or meters. This gives us units like milligrams, millimoles, milliseconds, milliliters, and millimeters. The prefix milli with a symbol of m represents 10 to the minus 3. This means that 1 milligram is equal to 10 to the minus 3 grams, or 1/1000th of a gram. We can also write this relationship another way by multiplying both sides by 10 to the third. This shows us that 1,000 milligrams is equal to 1 gram. In other words, it takes many small units to make one larger unit. Let's work through an example problem. In X-ray imaging, kilovoltage peak, or KVP, influences image contrast. A higher kilovoltage peak produces a lower contrast image because it creates more shades of gray. How many volts is 95 kVp? First, determine which unit is larger, volts or kilovolts. Kilovolts are larger because the prefix kilo represents 10 to the third. 1 kilovolt is equal to 10 to the third volts. Since we have 95 kilovolts, we multiply both sides by 95. This gives 95 kVp equals 95 times 10 to the third volts. Evaluating this expression gives 95,000 volts. Now let's try another practice problem. Match each measurement to the correct object. The measurements are 7 micrometers, 110 picometers, 90 nanometers, 5 millimeters, 40 megameters, and 5 kilometers. The objects are the circumference of the Earth, the distance some people run for fun, the length of a grain of rice, the size of a red blood cell, the size of an HIV virus, and the size of a cesium atom. To solve this problem, recall that the microprefix stands for times 10 to the minus 6. Pico represents 10 to the minus 12th, nano represents 10 to the minus 9, milli represents 10 to the minus 3, mega represents 10 to the 6th, and kilo represents 10 to the 3rd. The largest value corresponds to the largest positive exponent, which is megameters. Therefore, 40 megameters matches the circumference of the Earth. The smallest value corresponds to the most negative exponent, which is picometers. Therefore, 110 picometers matches the size of a cesium atom. Among the remaining values, 5 kilometers corresponds to a typical running distance, often called a 5K. A grain of rice is about 5 millimeters long. A red blood cell is approximately 7 micrometers in size, and an HIV virus is around 90 nanometers.